Hi, sir. Thank you so much for joining today. Deepak sir completed his PhD in 2015 from the University of Rome. And for me, he has been very important because he always appreciated the way I can think for things. So that always gave me confidence that even if I may not be the best engineer in the world, but I will definitely be able to do productive things in my life. Not only you taught us electronics actually, but you also taught me how to play badminton. You had really good smash. I still remember. But it will be like my first official podcast. Also, I had two or three before, but for AI Miss Marketing, you are probably the first outside guest. Sir, why don't you tell me more about you and your current research, what you are doing?
Okay, so first of all, thank you very much for giving such a beautiful introduction. Okay, and it's always been a pleasure to talk to the students who did very good in their life, not only in terms of education, but also in terms of the social contributions that they have provided. So, now coming to my area of research and my area of work, I after completing my PhD in RF domain, I joined LNMIT in 2016, and since then I am working here and teaching students in electronics and telecommunication department. My area of interest always aligned with the microwave and RF engineering, and apart from that, now I have also studied and worked with the embedded systems, and right now I am focusing on developing solutions for the societies.
So I will try to make it more, let's say, comfortable to understand for general public as well. So if you can tell us like what are embedded system, like
So, if we talk about embedded system from common man's perspective, then all the electronic items that people use in their home or in their general life are in
definitely
one way or the other way are embedded systems. For example, most commonly used electronic devices like television.
because they are a group of multiple systems and multiple
Right,
circuits.
multiple systems are there. There you have lots of microprocessors, embedded chips, and all.
Hmm.
Similarly, mobile phones, even the remote, everything that you see around you, if it is an electronic device, then definitely we have embedded so many things in that. But when we talk about embedded as such, or especially when we focus on that word embedded technology, then we include some part of programming also. So it
Right.
is not only the body, that is the hardware that you see around, like the LED, okay, or the beep or speakers. Apart from that, we also do some coding to give a soul to that hardware. So in Diwalis, you might have seen strip of LEDs which are blinking in different manner. So LEDs can be on or off, right? That's their property. But making it blink in a certain pattern requires some brain.
Right.
So we are providing some brain to that LED strip also, which
So,
makes our life more beautiful.
so are you saying that you are also giving some artificial intelligence to these LEDs? So,
Indeed, this term which is coined artificial
yeah.
intelligence, actually nowadays we are hearing it more. But if you talk to any engineer, artificial intelligence is there since 1950. Because if you are writing a code for the hardware, directly or indirectly, you are providing some intelligence to that system. Might be possible that system is not very intelligent, but at least it has got a small intelligence in it. Like for example, when you press a number or when you dial a number, okay, why that number goes to a certain another phone number and how it actually connects to that. So there is an intelligent system working behind it. It is artificial, yes, because we have made it. Is it intelligent? Yes, it is intelligent because it is only communicating to that number only.
Sir,
It
why
is not.
don't you explain how a phone call is made? Because there are so many variables that go around in making the phone call and reaching to the right person. So that when I call my friend with his 10-digit phone number, it actually reaches to my friend and it does not get lost. And he's even if he's 2,000, 5,000 kilometers away, its signals are able to reach to the right person.
Right. If we talk in a very simple manner, Okay, so basically we are playing around with frequencies. Now, when we say what are frequencies, everything that you see around you does have some frequencies associated to it. Be it your sound. Okay, sound has some frequency. Okay, a flute, they have their own frequencies. Drums, they have their own frequency. Similarly, when we make a call using a mobile phone, okay, we play around with frequencies, because now, for example, when we speak, the sound travels from one person to another person, but it cannot reach to a person which is who is actually 10 kilometers or 50 kilometers away from you.
Right.
Then we are actually connecting a person who is thousands of kilometers away. For that, researchers tried to figure out frequencies which can travel far, because the atmosphere absorbs the sound, because you know that when the sound travels with respect to distance, the sound degrades or the volume goes lower and lower. So, and then light also travels from sun or from stars. They travel billions of kilometers or light years. They travel and they reach to the earth. So that means these frequencies can travel. So what if I can add some of my frequency with such frequencies which are already traveling or which can travel longer distances? So that gave the genesis of modulation. So you have one frequency which can move very far or which can be made to travel very far. And if I add my frequency to that, that is my sound. Okay. So suppose if I have a very high frequency like 2.4 gigahertz, in that, if I add my sound,
Yeah.
so mix them and give some power to that and let them travel in the air. And once they travel, at the receiver end, what we do, we will try to figure out who should listen to such a frequency. So we did, we coded every instrument with a number. That is our mobile number, right? So only the person who has to listen to such a frequency will be given a code, that is our phone number. So the signal which was generated from my end will travel to that distance via base stations, mobile or via satellite or via fiber optic. And then the person who has the same decoding code, which is the receiver's phone number, okay, will be able to listen to the message which I wanted to communicate. Rest of the people around that signal will not be able to listen to that. Okay, let me give you a very simple example which I always use when I teach to the students the concept of this signal traveling and receiving. So if you take this pen, for example, this pen, in the tip of this pen, you have almost all the channels, TV channels, FM, AM, okay, all the signals that are transmitted in the air. So only thing is why we are not able to listen to that video or the recording, because we don't have an appropriate decoding system. For that, you have to put an antenna here and some electronics to decode that. And if you can do that, you can get all TV channels in my fingertip. You can get all the AM, FM, all the songs, videos, whichever signal you want to listen, everything is here. But
So, sir,
only thing I
that
require,
brings us to antenna, and this is where and receiving it.
yeah,
Uh,
antenna is the first step to receive the signal. Then, because the signal is very weak, like I gave an example of sound. When I speak to someone, that sound will travel, and with respect to distance, the sound will degrade. Similarly, the signal which was broadcasted from my end will travel to thousands of kilometers via maybe base station and or satellite. It will be very very weak. Okay, might be in some microwatts or picowatts. So then the antenna receives that signal, and because the antenna is receiving so many such other signals also, so first thing that we need to do is take that signal, filter out the signals of our interest. Understood? It is just like you are getting so many data or you are reaching to a library, but again you will have to filter out a book which you are interested in. Similarly, we have filters, electronic filters, which will filter out that frequency, and then you have demodulators which will demodulate that signal, and then amplifiers to raise the signal's power. And then you can use your headphone or any other speaker or television or monitors to regenerate that same signal with the same strength or maybe more strength also.
So what happens that there is in my phone there is some carrier frequency of probably 2.4 gigahertz, whatever frequency it is, and then my sound is added to it. Now this sound travel through air, and then probably whatever the right key is, it goes to the my friend whom I'm calling, and then that phone who has the key to this particular communication, decodes it, and then through antenna it receives that communication, amplifies it, and then I'm able to listen to this conversation.
Right. So it is not that simple, because now just imagine so many signals are there in the air. Television signals are there. You have walkie-talkie, which is used by the police. Similarly, you have AM and FM signals broadcasted by the radio stations. Then you have mobile signals generated by the users. So millions and millions of users are using these mobile equipments. So actually, you or anyone right now is actually going through called.
Like suppose I am stuck in this mesh of signals, and then somehow my phone is able to decode that. So it must be a very complicated process, right? So how does
Right,
it?
right. For just give you an example in another way, the sunlight, right, which reaches to us. So when we were in the school, we were told that the sunlight do not have any color as such, right? But the moment we take a prism and pass that sunlight through that, we start seeing different colors around it. So basically, what is the prism doing here? Basically, prism is decoding all these different colors which are present in the white color, which makes the sun's light is colorless, we say, but actually that has so many different colors in it. Only thing you needed is a prism to demodulate it and generate all the colors within that so-called white color. So white color actually contains almost all the colors in the universe. Okay, so only thing that you need is a proper demodulator. Similarly, you are surrounded by so many signals, not only the signals which are generated by human being, but also the signals which are coming from different stars, planets, because they are radiating something. And if there is a radiation, then definitely you are generating some frequencies. So if you want, there are many good videos in which they regenerate the sound of the earth itself. The earth is also generating sound. So scientists are using technologies to listen to the earth also, so that they can know what is happening inside the earth, that is at the core, what is happening in the core, how or when the earthquake may come, how the core is rotating, how the magnetic fields are changing. So everything associated.
Every object has its own natural frequency.
Right, right, right. Even you or me, when we are sitting on a table or a chair, right, we are also radiating something. Because of that, when you use the equipments, okay, or the what we can say infrared devices, we can from very far distance we can predict what is the temperature of your head, your nose, your eyes, your hands, because we are generating different colors. So we are also radiating different frequencies, or we can say even our body parts are radiating different frequencies. Only thing you need is decoder for that.
Sir, you have studied antenna extensively, and people say that if you know how to make antenna, you can receive any signal. So my question is, do you ever pay for your Tata Sky or any of these signals, or do you make antenna for them?
Antennas, okay. Basically, these are metallic sheets or metallic plates, or sometimes even metallic wires. It has to be just metal. That's all, because you have to have a conductor to receive the signal. Okay, and these conductors should have a proper length or dimension. So suppose if I am saying that I am generating a signal of frequency f. Okay, so the frequency f can be translated to wavelength lambda by using a very simple formula. Now, the antennas generally are designed around lambda by 4. So whichever signal you want to receive, okay, you just have to have any
Why
plate.
it is designed by lambda by 4, not lambda by 2 or lambda by 3?
Okay. Now, if you talk about the lambda by 4 part, so every sine wave you take. So we start from 0 degree, then we reach to 90, then 180, then 270, which is going down, and then 360 back to 0. So this is your one lambda, right? So if you take, because now if you make an element of length lambda, you are always at 0, 0. Can you see from there? Because you started from
Right.
0, you reached to the highest peak, then went 0, then lowest peak, then went 0. So this is one lambda. So if I make it, if it's shorter, 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 I will reach to a point where I will get the highest peak and the lowest peak of voltages. Okay. So if I take a lambda by 4 length, then what will happen? I will be always getting peak of positive and negative, which will oscillating like this. And that maximum voltage will allow me to generate current. right? So the antenna which is receiving these voltages, okay, if I make this wire lengthy, then what will happen? I will always get highest peak of positive, negative, or positive, negative, and I can decode a particular frequency from that. So this is
So
the
I can generate
basic concept.
maximum amount of current if I use lambda by 4.
Right. And it is associated to a particular lambda also. So you are actually decoding a particular frequency also indirectly, we can say. Because if you change the length, every time you change the length, you are changing it by some lambda. So it is also
That is
correlated.
why you need specific antennas.
Right. So in your past, when we were, or if you go to the past, when we were having televisions, we used to have Yagi-wood antennas, which used to look like the bones of a fish, and we used to rotate it in a particular direction towards the
Yeah.
station, broadcasting station, so that we can capture the signal. Even
Yes.
that same antenna is used nowadays also. It is very directional antenna. And then came different antennas like dish antenna. So basically, if you take the concept of dish antenna that you were asking about, that we use to capture the satellite signal, so what we do here is that we create a parabolic dish like this. Assume this is just a glass, okay, mirror. What will happen if I take a mirror like this, of this shape, and I, okay, incident a light on that? What will happen? All the lights will come, or the stream of light will come, and they will reflect back, right? But they will reflect back in a different function. That means all this light will go and converge in one particular point, and at that point you will get the highest heat or light at
Highest
that
energy.
particular point. That is what we are doing here also, because in the, from the satellite, when the signals are transmitted, they are of very weak signals, which when we receive at our buildings, or which we receive at our roof. So what we do, we use parabolic antenna. So all these signals come to these parabolic
These
antenna
signals
and
are so
converge.
small, like 1 billionth of a volt.
Yeah. So now what you do, you converge that to a focal point, and there you have the receiver. If you carefully observe, these parabolic antennas always have something in the center, somewhere here in the focal point, because these signals which are received from the satellite are focused to a particular point, and there you keep the actual receiver, and then that receiver travels to your set-top box for the processing, like I said, filtering, and then demodulation and amplification. So this is the role of your antenna. That's all. Basically, capture a signal, focus them to a particular point, and then travel them to your set-top box.
So that reminds me, and I have read it. And then if you go on YouTube, there will be many conspiracy theorists, and they will say like 5G is very dangerous. The signal is coming is so strong that all the birds will die and people will get cancer and all. If you want to talk about it, is it the case? If not, like,
Okay.
yeah.
So now this concept of cancer and radiation and no hazards of 5G signals and all. So why such propaganda? Not propaganda, but why such rumors are spreading? Because now when we talk about different technologies which we are evolving around, for example, first we started with 1G, then we went for 2G, 3G, 4G, 4.5G and 6G, or 3.5G, 4G and 6G. Now we are planning about 6G and all. Now, whenever we talk about these generations of communication, starting from first G to fifth G, we are actually changing some of the bands of the frequency, right? So in 1G, we were using one particular band, then we moved to another band, then we moved to another band, and we are using different signals also, more complicated signals, because in 1G you were getting very low data rate, which was basically no data rate was there in 1G basically. Then we in 2G we started with maybe 9 kbps, which is a very slow data rate. You cannot watch a movie using that data rate. Only thing that you can do is you can send messages, text messages. So at that time we had SMS only. Then came 3G, which actually increased the data rate. In that we were able to see videos at a very low quality. So what is actually happening in the background of this 3G and 4G? We are generating more complicated modulated signals. Okay. And we are using different frequencies, because already one for 2G we have allotted one frequency. So you cannot reuse that frequency. So you go for another frequency in 3G band, similarly for 4G and 5G. And these signals are having different bandwidths. Okay, I'm not going into that detail because that is more, we can say, communication oriented, and or we can say it is more engineering oriented, might not be that useful for common people. So the bandwidth is also increasing and the power, okay, is also changing. But if you carefully observe, these frequencies are used for many other purposes also. Like in your home, when you use microwave oven, in the microwave oven we use the same 2.4 gigahertz to bake our items or to bake our food, which takes some maybe seconds to prepare rice or prepare cake and so. People what
Actually,
they
that
think,
is their that is their logic. If it can bake the food, why can't it bake us?
yeah, they can bake us, they can change our cell structure and all. But the problem here is that that 2.4 gigahertz in the microwave oven is actually working at a very high power. The power is the factor here. When we talk about 2G, 3G, 4G, we are actually changing the power of the signal also. So if you talk about the standards, so communication standards are basically controlled by some regulatory institutions like 3GPP. Okay, one regulatory institution is 3GPP. They specify everything that if you are using, for example, a mobile, you can generate this much of power in this frequency, in this particular generation. For example, your routers that you use in your home, okay, Wi-Fi
Yes.
routers, they can generate 2.4 gigahertz and 5.8 gigahertz. But
Mhm.
for them also, they have restricted a power that such routers cannot radiate their signals beyond a certain power. Otherwise, what will happen if you transmit a signal with a very high power in that frequency? Of course, that may burn your skin or that may cause some harms to you or your body. So there are regulatory bodies which actually analyze everything before launching a particular technology. So I believe the scientists who are working at the background, okay, who are developing these standards, have more knowledge than the common people who are spreading these rumors. Everyone, be it a mobile manufacturer, be it a router manufacturer, or any other wireless system developer, he will have to obey the standards provided by the 3GPP, similar regulatory authorities. So we cannot break those boundaries. The moment we break such boundaries, we are liable for jail or punishment under the government laws. So no company, no mobile towers generally radiate signals beyond the prescribed limit. So such rumors shall be kept apart, because otherwise what would have happened if we can come across a single case, okay, that due to the 5G signal someone has no cancer or someone got cancer, then in that case he can challenge the regulatory bodies or the companies which are radiating such signals, and he can file a case against them and get millions of dollars of reimbursement. And right now I have not came across any such cases, or might be possible. If so, I don't know right now. So I still believe the regulatory bodies are doing their jobs properly, and whosoever manufacturing the equipments, be it mobile phone, routers, remotes, or walkie talkie, they are still generating signals which are safe for human beings. Okay, we are not into
So unless
the,
you have antenna in your body,
such radiations.
these principles of communications are not only used in mobile phones, but they are also used in day-to-day devices, even automated cars and robotics. So will you like to talk about it?
Yeah, for example, communication is required for everyone. Okay, from human to human, bird to bird, animal to animal, everyone is communicating, right? And of course the way of communication are different. When we enter into the electronics domain, or we say the domain of communication in electronics, what we are doing is we are just using the different technologies to make these messages or signals travel to different places with different speed. Okay, so that the data rate can change, the quality of the signal can change. So all the science behind it, okay, are evolving accordingly. So first we developed systems which were for mobile communication, because human being wanted to interact with each other at long far distances. Then we started deploying such technologies in almost everything. For example, smart home. Okay, so in a smart home you are going to have an IoT system or internet of things, where you will have a camera, you will have an alarm system, or you will have even systems by which you can see what is happening inside your house using Wi-Fi modules. So the things kept on evolving, and now if you see, we have automated cars or driverless cars, okay, in which again these cars are communicating with each other so that they can maintain a safe distance, they can maintain a safe speed, they shall not hurt any human being. So for that,
Self-driving trucks and cars.
yeah, self-driving trucks and cars, so that we can avoid any injuries to the human being or any other animals in that case. So what we need to do is we have to communicate. So for communication we use, if we talk about human being, okay, we communicate based on the things that we have learned or seen around us. For example, we use our eyes to see things, we use our nose to smell things, we use our ears to hear things, and based on that we communicate with the people, okay, based on our knowledge. Similarly, the cars nowadays are using cameras, they are using Wi-Fi signals to see what is around them, to measure how fast they are moving, and to check what is the traffic condition. So for that they are collecting so many data around them, and based on that they are communicating with nearby cars or other automobiles. So such communication systems are not only for human beings. Nowadays they have crossed the boundaries of human beings, and now we are using such systems even for, like we said, dead things like cars or robots or such things. So what we are doing is we are giving some sort of life to them based on the experiences that we have learned from generations. So that is what we are, like I said, we are giving them intelligence.
Yes.
So first part of intelligence is the communication.
Right.
How you spread your knowledge, how you share your knowledge, how you communicate your emotions or your status or current state with some other person is communication. And that is what we are doing with the non-living things. Like in the past, we used to call them non-living, but now we are giving them soul, their own intelligence. So we are building so-called human beings,
Artificial life.
artificial lives. Yeah, artificial lives itself with some
So,
intelligence.
so like suppose all these devices in smart homes, and again, we can probably come to that we in India we have probably thousands of people doing research on them, and but I don't see anyone, at least in my knowledge, manufacturing these devices. Like, what could be the reason for it? And because I don't think it's just limited to availability of the raw products, because China does not have everything. They import the raw material and then next they export to the world. So where we lack and what we can do according.
Okay, this question is very complicated and not that easy to answer, because there is no one answer to such a question, because otherwise people would have figured it out and found
Right.
a solution for that. So it has, in my opinion, to find a solution for such a question, we have to analyze so many variables. Okay, when you take a complex equation, okay, be it from mathematics or from any other part of your life, because you can figure out what are the variables which are making you successful or which are making you failure. And when you analyze all those variables, these variables may have different weightages, and you have to tweak them so that at the end of the day you come up with a one wonderful equation which will give you success. So when we talk about manufacturing electronic goods in India, or IoT, development of IoT, development of robots, or intelligent systems in India, of course, we are not that good as China, or I cannot say openly, but we are not that good as China or US. Of course, we are developing, and we do have some companies who are working behind these technologies or who are working on these technologies. Although they are not that much successful, but we cannot say they are not doing anything. Because in my knowledge, I have many companies who are working in IoTs, smart systems, smart home technologies, even robots and all. Because now we can see many private partners are entering into defense also. Indian defense, they are manufacturing very complicated drones, they are coming up with robots, and of course smart weapon. Not only that, if you check ISRO, they are working on smart devices, because they are deploying so many rockets and satellites in the space that are using these technologies to analyze the behavior of not only the clouds or the rain, but also the vegetation, even the landscape or the rivers and everything. They are doing so many things. So we cannot directly say that no one is doing some working
So
in
my
IoT.
question was like, where do we lack? Is it because like why don't we have NLG?
We are not that good as China or US.
So, like, even let's suppose 20 years back, China was not so good in terms of quality, but they at least had the quantity. Why don't we have like our people even trying in the market? Somehow it feels like they want to make the products at the same quality level as of US, but they don't probably. It seems like they don't even want to go into the consumer goods or like the market of
Okay.
the general.
So if I talk about the some of the most important bottlenecks or most challenging jobs in developing such manufacturing solutions, then first of the biggest hurdle that I see is developing basic electronic items like semiconductor. Okay. So until unless we start manufacturing basic semiconductor devices like diodes, okay, LEDs, small ICs, triple five timer that you might have studied, or op amps, or similar other items or small items, we should start from there, and then we can gradually grow towards making microprocessors, microcontrollers, FPGA ICs, and so on, which are very complicated. And if you talk about China, or if you talk about US or Japan, they have spent a lot of time, and of course they have spent a lot of money in the research also, that we lagged, because in our system or in our country we were more focused towards software solutions, because we were booming and we were giving many solutions to different countries and different organizations in terms of software. So gradually our institutions, educational institutions, they focused more on the software part, because let me give a very simple example in terms of the expenditure that happens when you try to set up a software based solution and a hardware based solution. uh, a lab, if you want to establish a computer lab, okay, how many computers would be required in general in a college? Maybe 100, 200 computers,
Yeah,
right?
hundreds could do the job.
100 to 200 computers, and any reasonable college can install 100 or 200 computers by spending 50,000 rupees per computer. So by spending just somewhere around 50 lakh rupees, or maybe if I double that cost by spending 1 crore rupees, right, one can establish a reasonably good computer lab. He can procure some even softwares, or even they can use open source software in which they can teach coding, or they can teach different languages, computer languages, to the students. And these students, after graduating from such institutions, were getting handsome and good jobs.
Right.
Right. So the return of investment industry, education industry in our country was more focused on return of investment rather than thinking for a long roadmap to develop a country as such. Because in that case, we would have focused on both software and hardware. When the people were more money oriented, or they were focused on return of investment, they found a very simple solution, that establish reasonably good computer lab and attract the student, give them jobs in IT sector, and everyone is happy. So what happened with that? The core sectors like electrical
So it was easy to set up, it was
labs,
cheaper to set up,
right,
and then there were jobs also available in the
in the
market.
market,
So college was able to show, okay, I had engineering students who were able to getting probably 80 to 90% placements. So it
right.
was win-win for both.
Now, what happened with this is actually, this actually hampered the core sectors. Core sector, when I say, like electrical engineering, mechanical engineering, civil engineering. So just imagine how much you will spend to set up a civil engineering lab. First, talk about the space that you will require. Second,
Right.
the materials that you will require. Third, the raw materials or consumables that will be required. Because once you make a brick of cement, then it is not going to recycled back to cement,
Right.
whereas the computer in the lab will remain there for 20, 30 years. So you will have to keep pumping money in such sectors to grow. Even if you take mechanical engineering, you will have to spend lakhs and lakhs of rupees, not only for lathe machines. Apart from that, you will have to spend money for the raw materials like steel, aluminum, welding rods, and so on. There are so many tools around it. Just imagine, consumers will cost more than the computer lab. So gradually, all the so-called these sectors which were more focused on manufacturing, right, were degraded with respect to time, because people were having good jobs in computer sector. It was easy to get job. It was easy to establish colleges. But at the other end, it was difficult to establish colleges, difficult to manage such colleges, and it was slowly and slowly hampering the manufacturing sector on into altogether.
So that could also be the reason behind progress being little bit slow in other sectors.
Progress, when we say the word progress will include so many factors
So
like progress.
progress, when I say, is something like this: that in 1850s we had a bicycle, early 1900s we had 1880s, 1890s we had probably motorbike. In 1910 we had finally assembly line and Ford cars, and then if you read H.G. Wells' book in 1984, we were supposed to have flying cars going on that trajectory, but we don't have flying cars anymore. Yeah.
Not only flying cars, we are
We
actually
have
having.
helicopters, but
No, no,
like
no, no,
it's
not
not.
only flying cars. We are actually losing many jobs in the core manufacturing sectors in the motorcycle also. So that means we are losing the quality of motorcycle also with respect to time. Same for the cars also, right? So it is not that
You are saying quality of the motorcycles and cars are also going down.
if you compare the quality of softwares that were developed in 1980s with respect to the softwares which are being developed now, and if you compare the motorcycles that were developed in 1980s, that to the motorcycles which are developed now, the growth will have different slope.
Trajectory, right?
Yeah, because even now we don't have that much of smartness or intelligence in our motorcycles or cars or safety systems you talk about, any other feature, right? So our cars are not that smart, our cars are not that safe, not only because we don't have technology, but of course might be possible because we don't have that kind of manufacturing facilities. Otherwise, if we would have grown in both sectors parallelly, then might be possible we would have also driverless cars running in our country. Same might be possible we would have more smarter heavy equipments to make roads and bridges and railway tracks. We are still aligned with many technologies which are obsolete in many other countries. We are still using them. Why?
Especially in two wheeler.
Not only two wheelers. I believe in many sectors.
Like there are
In
people who are still using asbestos.
so manufacturing sector actually not only lost its charm. For example, not only don't look at the electronic part, look at the manufacturing of clothes. Yeah. So handloom technology, which was the core sector in providing jobs in India. So many people were working in that means
Right.
manufacturing in clothes and that.
Almost 1,000 years. They are complaining about that. They are rich people are spending all their money in India in buying the silk clothes, Indian silk.
Right. So clothing sector, then leather sector, then brick manufacturing or iron
Iron,
things.
the so-called Damascus steel was actually your steel that was made in the southern side of India, like more in Tamil Nadu and Karnataka.
So we have to come up a long way if we want to showcase our power in the current world in manufacturing, because I believe in the last 40 years we have lost a lot of things, lot of technologies, especially in manufacturing, and the world has grown very fast, and they have acquired technologies which I believe to replicate will further take maybe 20, 30 years in India. Even if you want to replicate that, it will take further 20, 30 years. So don't think that in coming 5 or 6 years something will happen in India and suddenly we will start manufacturing electronic goods. It is impossible. I can, from my knowledge, from my point of view, I can say it is impossible, because the technologies that have been developed and the technologies on which the other countries are working or developed countries are working are too complicated to be developed in India right now or in the coming 5 years, especially in manufacturing sector.
Means I remember like people simply don't manufacture. So, for example, I have worked in a company, rather consulted a company, and it was a big audio. I have consulted multiple companies, but I will like to give example of two. One is a auto parts manufacturer, and then second company is a electronics public address system manufacturer. So they were making amplifiers, speakers, microphones, all that. The one who was manufacturing public address systems, they were importing everything from China. Everything, 100%. Like, means somehow they feel like it's not profitable to manufacture in India. It's cheaper to buy something from China and then sell here in India, which I don't know how it makes sense, but still it does.
But that I said in the beginning, I said we are actually looking for return of investment rather than growth of country. Understood? So everyone is more focused on return of investment. Whatever I am investing, how much I will get back. They are keeping
I
aside the.
feel like not it's not even about the country. It's just like very short thinking. So they will also get better because in India labor will be cheaper anyway. So in a long period of return, probably 3 4 years after that, you will be making cheaper than China. So I'm not sure like where the things are getting lost.
Let me
Because
give another example. When I was giving you some examples related to the labs, let me come to the lab in which we work, RF and microwave. So I gave you an example that to set up a 100 computer lab or 100 computer based lab, you will have to spend somewhere around 1 crore rupees. Okay. But to procure one signal generator, only one signal generator in RF domain, which will be somewhere around 10 gigahertz, you will have to spend more than a crore rupees. One instrument, only one instrument, you
okay,
will cost 1 crore rupees. So
okay,
just imagine using just a signal generator, you cannot do anything. So for that, you will have to have a signal analyzer also to procure a 10 gigahertz signal analyzer. Further, you will have to spend 1 crore rupees or more. So just with signal generator and signal analyzer, you cannot do something. You will have to have instruments or like amplifiers, resistors, attenuators, antennas, and so on. So to establish one test bench only, one test bench. Okay. And then there is a vector network analyzer, which will cost further 1 crore rupees. So just by spending somewhere around 5 crore rupees in the cheapest mode, I'm saying, you will be setting up one test bench, only one test bench. Okay.
right.
So that means if you set up that test bench by spending 5 crore rupees, only might be possible 2 or 3 students will be working on that at one particular time. Whereas by spending 1 crore rupees, you are training 100 engineers in the computer lab.
Right.
Whereas in the microwave lab, by spending 5 crore rupees in the cheapest possible way, you will be training only 3 students. So just imagine 100 versus 3. So that's why if you roam around in our country, you will find very few labs or very few engineering colleges having facilities in microwave and RF. Because again, to set up a lab for 30 students, even just for 30 students, how much money you will have.
And government is thinking they can make a BrahMos in the same money.
Look, that's why what happens here is that we are developing rarest of the rare of microwave engineers. Okay, so if you talk to me or if you ask me where these engineers can work or what can they contribute to our society,
Right.
so these engineers can develop mobile phones, because for developing mobile phones you need very good RF engineers. They can
Right.
develop antennas, they can develop and filters, amplifiers, power amplifiers, you name them. Any technology around you will require RF in your hand. Even if you want to develop a hard disk or a RAM, you will have to have RF engineers around you. And how many RF engineers are we producing? Because of these constraints, we are producing maybe 0.00001% of the world, which is generated of the US, which is generating these many engineers. So most of our engineers, especially in RF domain, are moving to US because you get much reasonably good jobs, more number of jobs, and of course US is demanding for such engineers around them because they don't have that many engineers who can do good jobs. But also we are not producing such engineers. So whatever we are producing are going to US.
We don't even have companies to, work with that many
No, no, no.
sources.
But of course, ISRO, DRDO, they want engineers from RF domain and microwave. but because of the lack of facilities, only few colleges or universities are producing quality RF microwave
But
engineers.
my question will be like, if they need it, then why can't they train the current electronics engineers?
Because these industries are not directly correlated to the educational institutes. If you talk about ISRO or any other industry which is working on RF,
Means why can't ISRO set up a lab where they can select like top electronic students, let's say 50 students from every state, every big state, and then invite them to their lab and then
that
have a last semester and select half of them, something like that.
that should be the policy. Like for example, if you go through the last year's budget, you might have heard that 500 companies will be taking interns, training them, and then might be possible giving them jobs also. So such initiatives definitely might help in future, but the companies have to come forward to take such pain, because if the companies only look for return of investment, then I don't think we will be growing with the pace by which we can compete with other countries. We
But
are going slower and slower.
But again, it comes to short-term thinking, because if Nvidia was thinking about just quarter over quarter balance sheet in 2015, 2016, they would not have grown 1000x in 3 or 4 years. So it's also about your vision to see the future and bravery that is required from a CEO of the company. And this is where willpower also comes. So because in US they will spend $200,000 in a year for engineer. India may they will probably spend, even for the same quality of engineer, you can get probably 50, $60,000 in a year. So you are saving a lot of money, but still if you are not able to develop any LLM, it's a big question on the companies. And I don't understand this handout mentality that if anything goes wrong, go to the government. Why do you need a government when you have like 5 or 6 IT companies in Nifty 50? They are like billion-dollar companies, all of these billion plus dollar, and none of them have taken initiative to even make the LLMs. And actually, if they just visit all the IITs and NITs and even colleges like LNM IIT, and they hire, let's say, top talent like 2 or 3 people from every college, and they just make a team of 500. I know, like, just let them work. Even those guys will come up with LLM in one year or 6 months. But still, I feel like there is no investment mindset. It's all about get the projects, sell it to the Gora people, and then get money from them. Only earn in dollars.
Look, for example, if you consider some of the most successful institutions in India, okay, manufacturing or research related institutions, then of course ISRO will come in the top. In one
Right.
of it is having its own league, because when we were just no got the independence, at that time some people thought about not only about the institutions for education and food or ration. Some of them thought about satellite also. Some of them thought about how we can grow in the space. So there was a vision for that, and they knew that it is almost impossible to get a good stature in the market of space and aeronautics. Still, they had that vision, they had that dream, they were ready to take that challenge. Unfortunately, with respect to time, such kind of mindset and such kind of vision, wisdom, and challenge taking people or risk taking people, they depreciated from this ground. Okay, so education sector, again, if you see, more and more privatization of education sector took place, where again return of investment was most important. Then came engineering colleges. In 1980s or somewhere on 2000, you saw a boom of engineering colleges in India, where you saw engineering colleges were getting established in every look and corner of the cities.
Just sorry to interrupt, but I have who is giving permit to so many engineering colleges, like people who are getting, let's say, 1 lakh rank. Why they are getting admission? Like 1 lakh, 2 lakh rank. They should be probably preparing more and take. It's better to take them 1 year more gap than getting admission at 2 lakh rank.
But just imagine, like I said, there is no one solution to these problems, because what you will do with the rest of the population, because we are producing somewhere on 17 to 18 lakh engineers. And then if you talk about the medical doctors and doctors or nurses, lab staff and so on, then you come to the commerce sector where you have bcom, mcom, cas, and then you come to the arts sector where you have the clerks and managers and mbas, ias officers. So we have to have so many jobs in our country to accommodate all these people, because our population is also growing exponentially. And might be possible it will crumble with respect to time, because if we are not managing it properly, then this population will grow old and we will not be having enough support or enough technology to support them. More focused on how can I win the next 5 years election. Okay, so they are coming up with
Yes, sir. Both in democracy, that is very normal.
that happens. So sometimes, I'm not saying always, but sometimes rules and regulations or policies which gives too much subsidy, okay, without looking for the long term gain or loss, may hamper the status of a country. Because if you are not thinking about generating good quality engineers, good education, good medical facility, and so on, and if you are just focused on how to win elections year by year, might be possible you are causing more damage to a country than giving some benefit to a country.
Actually, I think the biggest example will be today's budget. They are giving 500 crores for AI, and they are giving
Mhm.
15,000 crores for agriculture subsidy.
So why the manufacturing is going down? No one cares about the engineering colleges right now. They are more focused on developing more and more computer science engineers. So computer science engineers are generating results from their end. But what about other sectors? Because we are not producing that quality engineers. So everything is correlated, I'm saying. You have to, again, you have to take all this data, put it into AI model, and find out the the most important factors, most important variables, work on it, fix it. And
We are producing, as you said, almost 1 lakh electronics engineers every year, right? In India.
no, 17 lakh,
In
17 lakh
India,
in
electronics,
India.
electronics engineers
Electronics somewhere around 3 or 4 lakh
every year.
every year.
3 lakh electronics engineers.
Yeah, yeah, somewhere around that.
So, like, where we are accommodating it and how we can improve
We
condition
are
for
not
them.
accommodating it. We are just leaving them on their own. Because
Okay.
look, you might have heard so many statements, or you might have got so many data related to the employment in India, right? And we came across, when we are in education, we always come across so many statements related to education. So now the stat says some of the people are, or some of the agencies who do this statistics related job, they came out with some numbers like more than 80% engineers are not, they are not even good for giving any sort of job. So they are not employable. So why we are giving these degrees? We are giving degrees to just make them happy and make them believe that they are engineers. But are they good to do anything? Because like I said, there are no good labs available. So these engineers, although they have the degree, but they don't have the required skill set to even change a bulb, to even solder a bulb, or to fix a motor part, or to fix a vehicle. So those who are actually not coming to engineering colleges, might be possible you will find many technicians who are good in these jobs. But engineers who actually have the degrees, they don't know how the bulb works, how the current flows, or how to design a switch using a transistor or a bjt or a MOSFET. These
So
are the
basically,
challenges.
there should be an audit of all these colleges.
People are doing audit until unless we, for example, there are auditing bodies like NAC, NBA, okay, AICT is also conducting their own
So
audits.
then why it's not working? Like, then where are the real labs?
Look, everything comes to accountability, like I said. So whosoever is giving good grades or good rankings to these colleges, every year you might have heard during the time of June or July, the admission time, the government releases the list of good colleges, right, under NAC. whosoever these agencies, whosoever is providing these ranking, is he or she liable to answer the common public that whether these colleges are really producing good engineers? If so, then why they are saying that 90% engineers are not employable?
Electronic students can become more employable side of the equation before we start.
So uh, now there are many things which we have to change in terms of, producing quality engineers, and some of the things that we can do even if the government is not doing, or even if the institutions are not doing. The students who are actually enrolled in engineering or electronics engineering in particular, because I belong to electronics engineering, so I can give suggestions in that domain in a more
Sure,
proper way rather than any other domain.
sure.
So what these students can do, okay, in my opinion, is that they can spend somewhere on 4 to 5,000 rupees. I'm not saying they should spend a huge amount, just 4 to 5,000 rupees at, somewhere on second semester. Okay, after getting enrolled into engineering, they should focus on the first semester, get adjusted to the environment, okay, study, focus, and then after adjusting, okay, it will take 5 to 6 months. Keep your focus on the engineering, go through the basic subjects, attend all the classes, and adjust. And then after that, after 6 months, you should buy some basic tools by spending 5,000 rupees. What are those basic tools? Like a multimeter, which will cost you somewhere around 5 to 600 rupees, soldering iron, 200 to 300 rupees, a roll of solder wire, maybe 200 300 rupees, and similarly a microcontroller or microprocessor board, and then some LEDs, switches, relays, and so on. So in by spending somewhere around 5,000 rupees, you can procure these items even from Amazon. Okay, or you can visit any nearby electronic shop, you can get all these items. Make a list of all such items and procure them. Then after that, while you are going through your syllabus, regular syllabus in second semester, third semester, and so on, try to build those things which have been taught to you. Don't just mug up the equations. Okay, if you are taught communication, try to build at least the most common communication systems by using transistors or by using MOSFETs, some capacitors or inductors. It will cost you somewhere around 200 rupees. So with this 5,000 rupees investment, okay, you can develop small projects. Okay, after developing that project, if you find that, okay, I understood the concept, dismantle the project, rebuild another project, dismantle, rebuild same project, another project. So you will be using the same components to develop almost all the projects that are taught in the engineering or the during this 8 semesters. So by the end, you will be having 5 to 10 projects in your CV, and that too which you have developed by going through the regular lectures. So that will give you a sense of what you have been taught. Apart from that, that will give you a confidence on how to build things around. Don't just rely on the labs, don't just rely or don't just blame the institute. Take your own stand, just spend 5,000 rupees, and that will help you for next 8 semesters or 7 semesters. Build your project, whatever is taught, cross check it, rebuild it, check their pros and cons, make your own notes. Of course, it will take maybe 2 or 3 hours per day, but by the end of 5 or 6 semesters, if you work in this fashion, I can guarantee you, I can guarantee you that you will be employable in any company that you look around, be it an embedded systems company, be it a communication related company, or any other company in electronics domain. So that part has to be, or that much effort has to come from the students end. Don't keep blaming, because at the end of the day, even if you blame, no one is coming to rescue you, right? So instead, take your own stand, attend all the classes regularly, just invest 5,000 rupees, and that 5,000 rupees will give you a return of maybe lakhs and lakhs of rupees in salary. So that is my suggestion to all those students who are looking for good jobs, and that in this process, if it continues and more engineers or students follow these steps, okay, they will create new scope, new companies, new startups, and might be possible this will give the so-called basic momentum in manufacturing sector, because all the things that you see around, be it in the scooters, okay, you have display panels, you have automatically sensing devices, sensors, wi-fi modules, okay, motor controlling systems and all. You can build it in your own room itself. You don't have to rely on very expensive labs until unless you are going for microwave. If you are still interested in robotics, embedded systems, or electronic related communication system and so, you don't have to spend too much money. Procure 5,000 or spend 5,000 rupees, and in future, if whenever you get a chance to work in labs like FPGA or VLSI related labs, I believe the universities generally have the FPGA boards and all. Talk to your faculty, get their confidence, work in the labs for 2 3 hours per day, and I don't think you will be jobless after 8 semesters. But if you move away from this, and if you keep blaming the system, or if you just think that someone will come to rescue you after 8 semesters, then you are in a totally wrong, what to say, world, and this will hamper your engineering and your career also.
So, is there any way AI can help these students? The chat GPT is there. They can know about what projects to make or
Right.
uh,
So now with the help of chat GPT or similar AI tools, you don't have to just always rely on your institute, because if suppose you are coming from a very poor background, and if you don't have the so-called privilege to study in some of the premier colleges by spending lakhs and lakhs of rupees, you can just have a small desktop, okay, or you can use your computer lab itself, sit there, ask genuine questions, discuss your problem with the chat GPT. Okay, ask them to provide the solutions, the codes. Even you can ask how these codes are built. You can ask how to further improve the codes. Spend some time, learn from the chat GPT or AI, because they will be guiding you in the absence of your quality faculty members. So nowadays, I don't think anyone can just blame on their institute or colleges for not having good quality faculties, because ChatGPT is available. You have YouTube where there are so many quality videos, lectures are there from MIT, from Waterloo, or name other Carnegie Mellon. So now we are not no running short of resources. Only thing is we are running short of, that means the enthusiasm, motivation among the students. If they are highly motivated, I don't think there is any lack of resources around them. In the past, of course, we were having these hurdles because we were not having that many books, quality books in our libraries, quality faculty members. We were not having access to the technologies which are being used by the foreign or big countries or developed countries. But now, with the advent of internet and AI, especially, you cannot sit idle and just blame the system. Use these resources and spend 2 to 3 hours. If you don't work hard, you will not get any results in the future. Just spend 2 to 3 hours. That's all. You will find that after 8 semesters, you will be having so many options, career opportunities around you, and you will get reasonably very good jobs.
is there way like they can do it cheaper and on their own rather than, and probably is there any project guide, or maybe probably in future you can, because this is probably a 3 years work, 2 hours
Right,
every day.
right,
So
right, right.
yeah, so
So,
it's probably 2 to 3 thousand hours that they will be putting in. So what should be they doing in those 2 to 3 thousand hours? What will be the approach?
so basically, when we start electronics engineering, we start teaching them the basic concept of electrical engineering, like
Right.
how the current flows, how the resistance actually lowers the current, what is voltage, what is inductor, what is capacitor, how you will make RLC circuits, and so on. So you basically develop the concepts which are governing the current flow and voltages and all. Then we introduce basic electronics lab, where you develop small circuits to validate or to cross check these concepts. Okay, and then for that, if you check the amount that you have to spend to acquire those components, it will be somewhere around 40 to 50 rupees. Okay, so you can come up with a list of equipments. Now there are so many websites which give you a list of basic components for starting electronics lab. Go to any particular website or go to Google and just type basic components to start electronics lab and make a list of that. Check in Amazon or check in any other online trading soft company, or you can visit nearby electronic shop, procure them, and I believe it will cost you somewhere around 5 to 6,000 rupees only.
No, so is there any YouTube channel they can follow where there is a step by step guide like what they can do? Or
Right,
maybe
right.
in future, because you also started your YouTube channel, so you
So,
can put a step by step guide. Actually, it will be very useful. I think this is something because everybody talks about the problems, but you talked about the solution beyond the IITs or NITs. So this is a big problem. So if anybody can put a step by step guide to what to do in 2000 hours, that will be, I think, very useful.
so there are many good YouTubers or even educators who are producing quality videos. Okay, so for theoretical part, okay, so if you want to study something related to theory, okay, in electronics, be it in microwave or analog electronics or VLSI, one of the most to say beautiful resource is NPTEL, okay, which is generated by or developed by the IITs. So you can follow those courses to to understand the basic theoretical concepts related to any particular technology. So give time to the video lectures by some of the most brilliant professors of our country. NPTEL is the best source for that. So after getting this theoretical concept, if you want to build something using those concepts, then I would suggest some of the good hands-on YouTube or YouTubers like EEVblog, okay, or you can go to ElectroBoom, or you can go to, I shall not be giving such names around, but what we can do is we
Yeah.
can share those in the description of the
Sure.
video. Okay,
Yeah.
so that they can click on any of those and they can follow the channel. Because
Right.
otherwise, what will happen tomorrow? Someone will say we were actually promoting those video channels, right?
But
So,
that's okay. They are doing a good job. To be honest,
right, right.
YouTube is an open source resource. So
Mhm.
I don't see any harm in that.
Yeah,
Means,
yeah. I can share a list of some of the
sure.
very beautiful resources which are totally free. Of course, apart from that, not only the educators, even companies are sharing quality videos. Like if you want to excel in embedded systems, okay, ST Electronics is producing quality videos and audio lectures,
Is it
not
a
audio.
India-based company or which
It's
country-based
an
company?
electronic company, ST Electronics, which manufacture microprocessor and microcontrollers.
It's in
They,
which country?
they're from US, I believe.
Okay.
So they have the MOOC courses. They have their own MOOC courses. So if you type in Google ST Electronic MOOC courses, you will find very informative, very quality, hands-on related YouTube videos, hundreds and hundreds of YouTube videos in where you can start from scratch to deploy AI in microcontrollers. That is one of the most beautiful resources. Then similarly, if you want to follow, there are quality videos from Texas Instruments. Okay, they are also quality IC makers, and you can follow their channel. Similarly, if you want to study about electronics, okay, you can follow analog devices. Okay, that's again a very big giant in manufacturing electronic components. So analog devices, just type analog devices, educational videos or educational lectures. Or similarly, for from any other company, if you want to know which companies are producing educational videos, educational softwares, so most of these companies are giving free licenses for educational purposes also. Some of them are time bounded, some of them are limited by some resources, but still you will get softwares worth lakhs and lakhs of rupees free for from such companies like Texas Instrument, ST Electronics. If you want to develop good knowledge in RF and microwave, ANSYS is providing educational licenses, and similarly, IAR is providing you educational licenses. You name the company, any reasonably good company, you will find educational licenses free for students, free for trial, free for demo, and so on. So you can start with that. You don't have to spend a single penny learn those softwares which are very highly demanded or demanding in the current manufacturing industries also. Unfortunately, these students are not utilizing such resources. They believe that everything is paid, but that is totally wrong. Indeed, we are also using many such softwares for free.
And so then why colleges are not using it?
I don't know.
This is a common sense things to do.
Many colleges are doing it, and many colleges they believe that there are no such facilities available. Might be possible they are happy with their regular no curriculum or their regular teaching materials, because most of the faculty members might be possible that they think that okay, whatever is there in the university syllabus we have to teach that, and our students once they will pass, we are happy with that. We don't have to take extra pain for this kind of activities. And many faculty members are taking pain also to teach students, to tell them or to make them learn about this kind of technologies. But for that, the faculty have to take extra pain. So there are resources. Now with the advent of internet and AI, like I said before, there is no hurdle or no restrictions in learning. Everything is boundaryless. You have the freedom to learn anything in this world without spending a single penny. It should be your motivation, your hard work, and your determination to continuously follow the difficult path. And then you will get all the success. But that 4 to 5 years you will have to spend in a very focused manner. Otherwise, resource wise, I don't think things are that difficult unless and until you are talking about some of the most complicated technologies. Otherwise, for basic understanding, basic things, even up to a moderate level, if you want to become a good engineer, you don't have to complain anyone now.
Who are manufacturing electronics products in India, but somehow they are not able to market it. Like, is there any
There
company?
are companies, but naming those companies right now might not be that good. So
Okay.
there are companies who are working reasonably good in defense sector. There are companies who are manufacturing medical equipments. Look,
Hmm.
if you take the share market, okay, if you
Hmm.
talk from the share market's point of view, electronic market can be divided into 5 to 6 sectors.
Okay.
So somewhere on 30% of the electronic comes from the normal user's product, or we can say day to day
Consumer
life
based.
consumer product, consumer items like television, mobile, telephone, remote control. Okay, so these are very basic consumer items. Then comes somewhere around 10 to 15% toys are used in electronic. Electronics items are used in toys also. So 15% to 20% sector share is controlled by toys. Okay, then comes your medical equipments. Okay, again maybe 5 to 10% electronics share market is controlled by your medical equipments. But then comes the defense, which uses somewhere around 5 to 10%. But if you check the proportionality versus complexity graph, then the consumer electronics is the most somewhat easier to produce, easier to deploy.
Right.
Then toys, very easy to produce, easy to deploy. Medical equipments, of course, you need very specialized equipments for that. You cannot have error in that. So it has to be produced in a very specialized manner. But the share market is limited, but very expensive, right? So the equipments that are produced in medical field are expensive, but the share market is small. So money wise it is very big. Then come defense, which is very less in terms of market share, but the amount is too high, too high. So even if you want to deploy a missile or electronic chip on a missile, cost wise it will be very high, but
Hmm.
demand wise it is very less because everyone is not buying those kind of chips for their home. This trade off is always there. Of course, automobile, there is a huge boom taking place in automobile sector also,
Right.
right? So if you divide these electronics, then these are some of the most demanding sectors. So engineer, if he is following any engineer, electronics engineer want to pursue a career in electronics, then he should focus on one of these domains, start studying things in that particular domain, then only he can become more successful. So you will have more probability to get a better job in that particular sector.
It's like Bruce Lee says, I do not fear the man who knows 10,000 kicks, but I fear the man who has practiced one kick 10,000 times.
And 10,000
So,
times, right?
thank you so much, sir, for your time. If there is anything you want to add before you leave.
Thanking you first of all for contacting me and conducting this interview. And of course, we should talk more about this kind of issues, okay? And figure out more solutions which can be deployed for normal people or common students. And we may come up with some good, reasonably good videos or suggestions to help the students in general. And for that, we can or we may meet again with more precise
Right.
content, more precise issues, and discuss it. Not only with me, might be possible we can include some other specialists from different fields. Okay, might be some good engineers from mechanical domain or similarly from computer science and so on. And of course, we should encourage our students to explore new things and to acquire knowledge from so many other resources which are there in the market, but they don't know it.
Next podcast, we can discuss about this employability plan that you were talking about, that invest little bit money and do these tools which you can probably find for free, and then probably become very employable and probably desired by many companies because you know a particular topic in so much strength and deep depth.
I'll be more glad to do that. Always happy to contribute in that direction.
Thank you so much, sir.
Subscribe to AME's Marketing and hit the notification bell so you never miss an update.